In previous videos, we looked at whether or not volatility has any correlation to returns in the stock market. And we found that with the S&P 500 stocks that we were looking at, there was no statistically significant correlation between volatility and returns. And so in this video, I've sort of combined two different things that I want to show you guys. One is using the Fred economic database. This is the St. Louis um, Federal Reserve Bank um, database, and they have tons and tons of econometric data sets here to look at um, that they update periodically and pretty regularly. There's everything from academic data, international data, prices on commodities, healthcare indexes, just loads and loads of good econometric data here for you. And then we're going to use that for electricity price and seeing if the volatility has a correlation to prices in a certain area. And then we're going to use the Spearman package inside of SciPy to calculate whether or not that correlation is statistically significant or not. So let's go ahead and get together everything we need. I've already set up my Fred key here to use, and it's a pretty simple way to connect to Fred. You just use the URL base. The endpoint is the observations. We connect that together. We throw in our key, and then we just put that in the parameters. Then when we use a request, that'll return a JSON, put that into a data frame. So it'll come with 3 columns of date times. There's the real-time start, real-time end. I just dropped those because I want to use the actual observation date, and I set that to a date time. The values also need to be set to numeric. For some reason, they come in as other, so just be sure to do that as well. And then I set the index to date. I rename the column the values to the electric price, and we'll call the beginning of it. Now, what this price is so like if I come to this here, this indicator is the key to the data set category here. So if I place this in here, you can see that what I'm pulling is the average price of electricity per kilowatt hour in New York, Jersey City, Pennsylvania, so the tri-state area. And the idea here is that we're going to see if this price has any, okay, and then we're going to drop that and plot the figure. Okay, so this already was showing what I was showing here. So this price is the price in that area between a little bit before 1980 to current day here, kilowatt hour in the tri-state area, right? And so my idea here is we'll calculate the volatility for this price, and then we'll find a stock, a utility stock for electricity for the tri-state area, and we'll see if there's any correlation between volatility and the price of that stock as well. So we calculate the volatility. I'm using a pretty simple calculation for volatility, which is just a rolling window of 6 standard deviation. This did take some, like how to choose the window. There's no great way of choosing exactly what number to use. I use 6 because if we look at our date frames, it's by month. So each price point is just 1 month over the other. So there's not like it's not day by day, essentially. So I use 6 to show us what the volatility is between like a rolling 6 period standard deviation, right? So, okay, cool. We have that. Now it's time to get our actual, we're going to use Con Edison. So I used to live in the tri-state area for a long time, and I used Con Edison as my energy provider utility company. They're a very old company, so there should be plenty of data on them, and I just pulled that close data of that stock based on the same time frames that I found here, right? So we're using 78 of November all the way to 12/1, which is the last day of our data frame here as well. So the prices should line up when we use an interval of 1 month, and then we're just connect them together after we calculate the volatility using the same rolling bit here. We can concatenate everything together, and now we have our electrical price and our Con Edison price as well as the Edison volatility. So the idea here, or the test that we want to attempt, is to see if there's a correlation either between the electrical volatility of the price and the literal Con Edison stock price between the same time frames. And when we plot it, we are just plotting the Con Edison price here over time. We can do a Spearman plot here. So what this plot does is it's a joint scatter plot that also shows the distribution of data points on the axes here, where our target is the electric price. So in our data frame, we're saying we are going to use this metric, and we are going to, the electric price is our target, and the Con Edison volatility is our metric. So we're asking whether there's a significant statistical correlation between the volatility of the Con Edison the volatility of the Con Edison stock to the literal electrical price per kilowatt hour for the area as well. And you see that it's 0.8, which in most, I think, statistics, the standard is like 0.5 is where is the threshold to say there is like some statistics significance here. And so as 0.8, we can say there is like a statistical significance between the volatility of the Con Edison stock to the actual electrical price for that area. And Con Edison does serve the tri-state area mostly, so that's why I chose them. So yeah, there is like a significant correlation there. You could then build off a strategy knowing that you have some way of measuring whether or not the volatility of Con Edison is going to go up or down based on the target price of the area at the time, or vice versa. If you like what I'm doing and you like these videos, consider going to this Ko-Fi link. It's a donation page or a tip jar where you can put in a one-time donation if you'd like. It really helps support the channel and helps me not feel like I need to shill out a sponsor or put out a Patreon or a course, and just focus on making these videos and putting these out for free. Cool. I hope you enjoyed it, and I'll continue to do other videos like this where we can find statistically significant correlations between two things. Anyway, I hope you enjoyed it, and I'll see you in the next video. Bye.